All right, let's go ahead and get started. I'm assuming neither of you have any additional questions, so I'll just go right into the new stuff for 220, 230. If you do have any questions, just you can raise your hand, and then I'll say, I'll say your name, or you can just go ahead and unmute or type into the chat. So what's new for you guys this semester is going to be the infusion rate questions. And basically what you're going to see is questions that look like this, where it's going to tell you have 0.45% normal saline, 1,000 milliliters, with heparin, 25,000 units. It's infusing at 500 units per hour, and then you're going to need to convert that to milliliters per hour. Alternatively, you might see the reverse of that, where it's going to give you milliliters per hour and ask you to convert to units per hour. Although I have to say, I don't think you're going to see that on your test. I think that's more of like an ATI type of question. But I'll give you an example of one of those, just so you have that. And then I think I repeated this question, so I'm going to get rid of that. But for the most part, you're going to see things like converting units per hour to milliliters per hour. And what I'm going to show you with heparin also applies with insulin, okay? So if you're wondering, is there a correlation with this? The correlation really just comes down to, or the math is the same, the setup is exactly the same. So I'll show you a couple examples and then go from there. And then we'll work through the heparin protocol, and then I'll give you a alternative heparin protocol, and then I'll mention the reconstitution again. I did go through this on Tuesday. I did record the session, so if there's anything I miss, you're welcome to go through that session as well, and that way you have everything covered. So for the infusion rates, let's talk about those for a moment. So this first one on heparin, it says heparin, or we have 1,000 milliliters or a liter IV of heparin, 25,000 units. It's currently set to infuse at 500 units per hour. What is the flow rate in milliliters per hour? So what I mentioned on Tuesday is all we're really doing is going from one flow rate, meaning units per hour, to another flow rate, which is going to be milliliters per hour. So the trick is, how do I set that up? So you're going to set that up, and I'm going to show it to you in the way that will also translate into what you're doing in the heparin protocol. So what I would start off with is your flow rate, 500 units per hour. And then what you want to do is you want to convert units per hour to milliliters per hour. And you're going to do that using your given IV. So you have 1,000 milliliter IV, 25,000 units of heparin, and that's the information you want to use in order to get your calculation. So I'm going to write 1,000 up here, 25,000 down here, and then you set it up right, because the only thing you're left with units wise is milliliters per hour. Even if you don't like doing, and I know that looks like 1,680, but let me just correct this here, 1,000. All right, that looks awful. That's okay. You may not like to do dimensional analysis, but I can tell you that it will help with these types of questions, setting it up that way. So I'm going to take 500 times 1,000, which gives me 500,000 divided by 25,000, and I'm going to get an answer of 20 milliliters per hour. Now, if I wanted to get or if the question got asked and it was an inverse relationship where it's asking to go from, again, flow rate to flow rate, but this time it's going from milliliters per hour to units per hour, I'm going to do the same thing. I'm going to start with my 20 milliliters per hour. I am going to get rid of milliliters and convert it to units using what I have available in my IV. So 250 ml, 25,000 units. I know I've set it up right because I've canceled milliliters and I'm left with units per hour. So I'm going to take 20 times 25,000, which gives me 500,000 again, divided by 250. And this time I'm going to get an answer of 2,000 units per hour. And like I said, I'm not anticipating that you'll have a question like this where you're converting it to units per hour, but I at least wanted to show it to you. All right. For insulin, the insulin questions are exactly the same. The insulin questions are just converting one flow rate type, units per hour, to another flow rate type, milliliters per hour. So I'm going to do the second insulin question. So I'm going to start with my flow rate of 25 units per hour. I'm going to see what I have available IV wise. So I have 250 milliliters and there's 50 units. I know there's a lot of numbers in here. So like the 0.9% just tells you what the sodium chloride concentration is, or yeah. And then the human R regular U100 just tells you the type of insulin, but it's the 50 units and the 250 ml that you really care about. And just like we did previously with the heparin, I'm going to get rid of units, convert it to milliliters via my IV bag. 25 times 250 divided by 50 gives me 125 milliliters per hour. So like I said, this is, it's more straightforward than maybe you think, and it's just a lot of repeat questions. We're just changing the medication that we're applying it to. All right, let's jump down to the heparin question here. Now, what I'm going to do is I'm actually going to change the patient's weight. Let's make it, let's say, one. Oops. Let's make it one. Let's just say 168 pounds. All right. So whenever we're doing the heparin protocol, first of all, what I've boxed here and what I should have boxed when I originally made these questions is just the standard heparin protocol. It's the standard weight-based heparin protocol. If you do a Google search for weight-based heparin protocol, you're going to see this out. So what I crossed through are the extra things you don't need to worry about in order to answer the heparin question. What you need to worry about is converting the patient's weight in pounds to kilograms. You need to know what your available is, which is stated in step 2 of the protocol. And you need to know what your order is. And your order is stated twice, right? Bolus patient with 80 units kilogram body weight, and then start a drip at 18 units per kilogram per hour. Then you're going to get asked 2 questions. You're going to either get asked, or you're going to get asked to calculate a bolus dose strength, and then you're going to get asked to calculate an infusion rate. Additionally, you might get asked as a separate question, or usually there's only one of these questions. It'll ask you after a period of time, they retest the APTT. They give you some number. Here it's 43 seconds. And then you're going to calculate the new bolus if needed, and then the new infusion rate again if needed. And so you can see where it tells you the details with the APTT. And they can even give you this as a question and just say, okay, what is the, they give you an APTT of 30 seconds, then you're going to need to rebolus with 80 and then increase the original rate by 4. And remember, the original rate was 18 units per kilogram per hour. So let's go through this with the new patient weight. And we'll do this one as well. Okay. So 168-pound person. So 168 divided by 2.2 gives me 76.36 repeating. So I'm just going to round that to 76.4 kilograms. And then I'm going to go ahead and do my steps. So I have a 76.4 kilogram individual. My order is 80 units per kilogram. Eighty times 76.4 is going to be 6,112. Units. And then I'm just going to convert units to milliliters. Now we're calculating a bolus, right? So I do need to pay attention to what my bolus dose strength is, and you want to make sure you're using the bolus dose strength. And notice the bolus dose strength is the 1,000 units per milliliter. Okay. So I don't want units. I do want milliliters. 1,000 units per milliliter. And so I'm going to get an answer rounded of 6.1 milliliters. So if I have a 176-pound patient, 80 units per kilogram body weight, 6,112 units, divide by 1,000, and I'm going to get 6.1 milliliters as my bolus dosage strength. What changes in a bolus dose question? Really, the only thing that changes is the patient's weight, but the math is the same. Multiply the patient's weight in kilograms times 80, divide by 1,000, and that's the standard for the protocol. I'm going to do something similar here with the infusion. Taking my same patient. Oops, left the thing here. So same patient, 76.4. This time the protocol tells me to start a drip at 18 units per kilogram per hour. So 76.4 times 18 gives me 1,375.2. And that's going to be units per hour. We don't want units per hour. We want milliliters per hour. So this is where I go to the heparin protocol or wherever it's stated my available. And I want to look for the 25,000 units, 250 milliliters, half normal saline. That should make sense. That's what we're using as our infusion and what our IV bag is. So I want to get rid of units, convert it to milliliters. My available is 250 milliliters, 25,000 units. And then I'm going to get an answer of 13 rounded 0.8 milliliters per hour. Now, from what I understand, you should be rounding your answer to the nearest tenth, even when it comes to flow rates. Although you may actually, in reality, set that to 14 milliliters. I can't definitively say that. All I can tell you is from a math perspective, you do want to round to the nearest tenth. That way you're making sure you're getting the correct answer. The only time you would round to the nearest whole number is if you're dealing with drops. And then that's where heparin is a little bit kind of different, is because we're not actually calculating drops per minute. We're actually calculating milliliters per hour. But it's going to be dripping, right? Because it's going to be coming out so slow. All right. So I'm going to change. No, I'm not going to change this up. So it says after 6 hours, we do an APTT. This is on the same patient. And we look at, and it says 43 seconds. And so we just do what it says to do in the 43 seconds. It says to rebolus 40 units per kilogram, and then increase the original rate. Remember, that was 18 units per kilogram per hour by 2. So that becomes 20 units per kilogram per hour. And so I'm just going to do that and just show my work. So we have a, oops. $76.45 or 76.4 kg patient, multiplying by the new bolus, 40 units per kilogram. 76.4 times 40 is 3,056. Units. I'm going to use my same bolus dosage strength, which was 1,000 units per milliliter. And what I'm going to get then is 3.056, so 3.1 milliliters for my rebolus. And then for my new infusion rate, again, 76.4 kg times my new infusion rate is increasing 18 to 20. So 76.4 times 20 gives me 1,528. That's units per hour. And then I'm going to use my same IV because they're still hooked up to it. 250 mil, 25,000 units. And I'm going to get an answer of, or a new flow rate of 15.3 milliliters per hour. So again, you may end up actually programming that to 15 in a real 15 milliliters per hour in a real life situation. But when it comes to the CCAC math bubble, just to the nearest tenth is what I understand to be the most correct answer. And then the last thing I'll mention is the flow rate question here. Oh, I'm sorry, not the flow rate, the reconstitution question. I'm not anticipating that you'll see this question on the test this semester, but you might see it in fourth semester, which is why I'm showing it to you. And this is why I also showed it to you previously in the or on Tuesday's review sessions. This type of reconstitution it just looks different. So if you do like a Google search, or even if you look on the OneDrive folder, I have some pictures of reconstitution labels. You will see a label that will give you the strength, 500 milligrams, but it's an intramuscular injection. So you know, because you've done these calculations, because you've done some of your clinicals at this point, you know that an injectable is going to be measured in milliliters. Normally, this would say 500 milligrams per ml or per 2 ml or per 5 ml, whatever it happens to be, but it doesn't say that. So that tells you that this is one of those labels where you need to look at the side. And then the side, you have to look in the directions where it tells you how to mix by adding water. You don't need to worry about the process. Really, all you are looking for is this right here, that the strength after it's been mixed, after water has been added to it, the strength becomes 225 milligrams per milliliter. That's the number you're going to use when you do your calculation. Okay. So the order is 0.375 grams. We convert grams to milligrams. We get 375 milligrams per 225 milligram times 1 ml, which is the quantity, 1.6 repeating, and then your actual answer is 1.7 mLs. So those are the things that I wanted to go over, just so you guys are prepared for that in case you see some of these questions. Like I said, I'm not anticipating you seeing this particular type of reconstitution question, but if I don't show it to you and it comes up later on, you might wonder how to answer it. So I'm going to go ahead and mute, pause. If you have questions, just ask away, type into the chat. If you don't have any questions, you're welcome to leave. You don't have to stay for the whole time, but I'm here for you if you have any questions.